Hi, so today in this video we're going to be covering chapter 5.3.2, which is properties of exponents with 0 and negative exponents. We sort of talked about this in our last video. I will quickly cover our exponent rules for 0 and negative exponents, but if you want a more in-depth view about the rules of exponents, please go look at my chapter 5.3.2 for a more comprehensive view on negative and 0 exponents. But basically, what it is if you have something like x to the negative 3, that's the same as 1 over x cubed. And if you have something like x to the 0, a to the 0, 10 to the 0, 999 to the 0, all of those equal 1. I go into more of the y in my last video, so if you are confused with that, please go check that out. You can find it in my channel in the 1015 videos or right next to this. So yeah, and I will link that in the description as well. Excuse me. So first, what it's asking us to do is to simplify each expression. We have y squared over y squared. Anything divided by itself is 1. So 1, z to the 5th over z to the 5th, 1. S to the 8th over s to the 8th, 1. Easy peasy. Simplify. Now we're minusing, right? So we have 1 to the t over 3. We don't want any negative exponents in our answer. We have 2 to the 3 over 7, to the 7, which is the same as 1 over 2 to the 4th. Excuse me. And then they might actually want you to simplify that into 1 to the over 16. Let me double check on that. Let me go question 4 maybe. I probably ought to have that marked down. So 1 over 16. Yeah, so that would be the answer for that. This would be 1 over s to the 10, because it's 1 minus 11, which is 10. You just kind of push them down. Push them down. If you were getting confused with these, if you're like, wait, how is she going so fast with that? Another way to do it, the more roundabout way, but another steady way to do it is to expand your exponents and say, okay, boop, okay, that turns into 1 over t to the 3, right? Yeah, that's an easier way. Not easier, but it's all about practice, I think, but that's one reliable way to do it. It's just sometimes can get really tedious. This one, we know that when they're together like this, we multiply and we distribute it. But be careful that you aren't just distributing it to the a to the 4th. We also distribute it to the 6th. So it will be 6 to the 4th, which I believe they will probably want us to calculate. So 6 to the 4th is equal to 1296. So 1296 times a to the 16th, because 4 times 4 is 16. This 5 will apply to the 7 and the y squared, so negative 7 to the 5th is negative 16807. It might let you get away with doing 7 to the 5th, but I doubt it. And then y to the 10th. This will turn into 1 over x to the 25th, because we multiply and distribute it through, and then s to the 45th. This will distribute out. We'll have g to the 24 times r to the 28, and this will do the same. We'll have, now careful, because it probably doesn't want negative exponents in the numerator, so we will a way to do this is still distributing, so we'll have h to the negative 14th times b to the negative 16th. But we'll just plop those under 1. We'll just move them down, because we're allowed to do that, and put a 1 over the top. Boop. So it will be 1 over h to the 14th times b to the 16th, and that 1 covers both of them. Next, we'll have simplify this expression. Now, this is where things get tricky, but only sort of, not actually tricky, because if you take things one at a time, things get really simple and really easy to manage. You just have to take it one bite at a time. The first thing that I recommend doing is multiplying this through. So don't forget, it also applies to the 2. So we have 2 to the negative 2, a to the negative 4, and b to the positive 6, divided by 2 times a, b to the negative 3, and c to the 0th. Now we know right ahead the c to the 0th equals 1, right? So we don't even need that. That's gone. We have no c's in this equation anymore. Now, this 2 to the negative 2 will be moved down. There are a few ways that I would do this personally. Now, I prefer the method of saying, okay, we're moving this down. This is technically 2 to the 1, so we're going to add 2 to it. So now we have 1 over 2 to the 3, 2 cubed, because we did 2, because we're moving it down, so we're adding the 2 instead of minusing because we're moving it. So it will be 3. Another way you could do this is you could say, okay, 2 to the negative 2 is the same as 1 over 4, right? But then we're still multiplying by that 2, which is 8. So we'll have 1 over 8. You always want to go further with the integers because it's one thing that you can do. This a, negative 4 plus 1, if it doesn't have an e, you can assume it's a 1. So we'll have a to the 5th. This b will move up because we just kind of we basically just want them to be positive. So they want to go upstairs in the party because they feel more comfortable that way. But these people want to go downstairs. So we'll now have b to the 9th. And this would be your answer. You don't technically need that one. So b to the 9th over 8 times a to the 5th. Simplify this expression. Write the answer with positive exponents only. Now this is where I see people trip up a little bit. When they multiply this x to the minus 3 by the x to the positive 7, they multiply the exponents. They do negative 21. But if you remember, when we're multiplying exponents with the same base, it will be adding, right? So we'll distribute. We'll do 8 times 7, k times k, x times this. The reason why, just remember that you aren't going to have any pluses or minuses in between them because it's still going to be related by multiplication. We're just combining like terms at this point, basically. 8 times 7 is 56. K to the 9th times k to the 6th is k to the positive 3 because 9 plus negative 6 is 3. X to the negative 3 times x to the 7th is x to the positive 4. That would be your answer. A way that you could have done that is you could have done 8k to the 9th over x to the x cubed times 7k to the 7 over k to the 6th x to the 7th, and then you would have gone 8k to the 9 times 7 times 8 is 56 times x to the 7th over k to the 6th, x to the cubed, and then these would cross out and minus, so you'd have 56 k to the k cubed times x to the 4th, which was our answer that we got. So you can simplify by moving things down if that's easier for you. I don't think that I have too much of I don't think it matters too much. My preference is doing the multiplication like I did in the first place, but either way works, and if one makes more sense to you, then do that one. Use exponential rules to write an equivalent exponential function with only x in the exponent. Answer should be of the form gx equals a to the bx. Express your answers using fractions. So gx equals. Now, this is where a lot of people get confused. And I think, personally, it's because we are scared of the word math. And we are scared and sort of like don't know what our next step would be in these problems. But if you remember our exponent rules and we take it one bite at a time and think about the problem and what it's asking, it becomes simple, easy peasy. So what we can do is, if you remember, x to the m minus n is exactly the same as saying x to the m over x to the n, right? And in our case, we have 5 to the x minus 2. If we do the same sort of thing that happens here, we would get 5 to the x divided by 5 to the negative 2. Positive 2, because we're minusing it. You could technically do 5 to the x times 5 to the negative 2, but it would be the same as this. We cannot cross these 5s out because they, it's not like, let me find an example. They technically aren't like terms. Like you wouldn't be able to cross out x to the cubed wait, hold on. Let me find an example. X, like 3 to the... sorry, I'm getting confused. Yeah, it's basically the exponents are not like terms either. So, yeah, I'm trying to find a good way to explain it. My brain has blue screened. Basically, you just can't do it. You can't turn that into a 1 because it would be different. The bases stay the same. You would lose the value of the equation if you did this. If you did 1 to the x over 1 to the 2, that would be different if you plugged in like 3 for x, because then you'd get 1 over 1 instead of, well, let's actually do t to the x. 2 for x, because that would be 1 over 1 instead of like 25 over 25. Oh, I guess it's maybe a bad example. Sorry, we'll stick with 3. 125 over 25. Those are not equal. Sometimes it's equal, like in the last example where we plugged in 2 for x, but it isn't equal for this one, because that will always be 1 over 1. So just don't simplify your bases. So what we have now is 5 to the x over 5 squared. That was a long-winded explanation. Using exponent rules, write an equivalent exponential function with only x in the exponent. Answer should be in the form h of x equals a times b to the x. So h of x equals, so we know that we can split this up. So we have 3 times 4 x over 3 to the positive 3. That's one thing that we have. Then what we can do is we know that when we have it multiplied, it's the same as saying 3 to the 4th to the x, right? That's one way we could do it. And 3 cubed is the same as 81, is equal to 81. And then 81 times 3, 3 to the 4th is the same. Wait a minute. Ooh, sorry. 3 cubed is 27. 3 to the 4th is 81. So we can change this. So 81 to the x over 27. This would be your answer, because x is the only exponent. That one's kind of tricky to think about, but we just basically are using our exponent rules and simplifying what those exponents mean. If you have any questions, please let me know, and I will answer as soon as I can. Have a good one.